comparison is happening between two columns. Okay, here you go. So you can see age versus, this is also age versus age. It is giving a nice histogram. If you see age versus, this is the CP, I guess, yeah, age versus CP, you can see both are categorical information, so that's why it is looking like this. And age versus this particular column, which is THALACH, it is looking like this. So basically you can see how the distribution of the data against each other. Hello everyone, how are you doing? So we have already seen some of the basic steps needed for the machine learning, data pre-processing, outlier management and everything. In this episode we are going to focus on exploratory data analysis. So what is exploratory data analysis? As per this is nothing but storytelling with the data. So that is the basic intention of exploratory data analysis. That's how I see it, right? So your data should talk to you. Your data should give a lot of information, insights by looking at it, by dicing and slicing about it. So today we are going to study some of the basics of exploratory data analysis by taking an example of the heart disease dataset from the archives from UCI. So the UCI university gives a lot of valuable data set for us for multiple exploration and also learning of about the data analysis. So this is the link of the data set I have given. So what is that data set is all about? It contains 76 attributes. All are published for the experimental purpose, and for the analysis purpose only subset of 14 of them have been taken. And there are 4 universities have shared the data: Cleveland Clinical Foundation, Hungarian Institute of Cardiology, VA Medical Center, Long Beach, USA, and then University Hospital of Zurich, Switzerland. So these are all the 4 universities have given the data set for the heart disease, and the more information about the data set has been given in this particular archive. I have copied and pasted from this particular website, and you can see the 14 attributes that we are going to use, and one of them is the predictor or the Y variable, that is NUM. All others could be considered as features. Okay, so you can see more details about what is age. We understand what is age. Sex is again the sex of the person, and so many other medical terminologies which we might not be able to understand, but for more details you can read this data set information, and then the information has been provided. And we are going to go ahead and see how we can go and do the exploratory data analysis. So before getting into it, so what we are going to do is we're going to understand when you start the data analysis, you do the basic analysis of the data, null values, which we have already seen in this particular video. You can click on the corner here, information button, the information what I have given, how to do the null value analysis. And we can also do data cleaning and scaling, which again I have discussed in another video. We can also do the data distribution, how the data is spread, and what are the outliers. These things are also be discussed in another video. All the video links have been provided here. This is specifically to do the single feature analysis independently. In this one we can also do little more analysis about how to compare the data columns, how are they correlated each other. So look for the correlations. So what is correlation? The change in one column impacting the change in the other column. That is the meaning of correlation. So how changes in one column is changing the data value in the other column. So that is the meaning of correlation. We will look for the correlation among the features and also with respect to the Y column, which is nothing but the predictor variable. Okay, so now let us start the notebook. So we are importing the basic libraries like NumPy, Pandas. We are going to use Seaborn library for some of our charting purpose, and of course Seaborn internally uses matplotlib, which we have already discussed, so we are importing that as well. We are going to scale our data using min-max scaler, so that's why I'm using that also. So basically that's what we are going to use. So these are all the 4 different university data sets have been shared. I'm downloading into 4 different data frames. Now all of them are having the same structure, so I can easily do the append function. So I'm appending everything into one single data frame. So all the data have been appended. So these are all the I mean, if you currently see how the data frame looks like, by using the head function, there is no column heading, which will be very difficult for us to do the analysis. So that's why I'm adding the column headings based on the description of the data set. So these are all the column headings. I'm adding those columns using df.columns. Now if you execute the df.head, you can see all the columns here. And so we want to see how many data rows are available, so you can use df.shape. You can understand there are 920 records of 14 fields. One of them is NUM, which is nothing but the Y output. It is having 5 different classes, 0 being no heart disease, 1 being 1 to 4 being different levels of the heart disease. So now we are going to see the basic information of the data set by using the info command. If we execute this 920 records, and then we can see there it does not look like I mean, there is no any null value, but we will come to see the null values little later, because some of the values have been replaced by question marks in the data set, which I have seen. So let us see how to handle that. Okay, now only 3 of them are having floating float 64, all others are objects. So we have seen in the previous video, when there is object, it means it contains strings, or it contains different types of data sets. It is not one single data type, so it will be very difficult to handle if it is just object. So next step is to convert all these things into float 64. So what we are going to do is create a define a function, convert into float, and pass all these things which are not converted to float 64 one by one using the apply function. So by doing this, all the things get converted to float. But here what happens is, if there is a string, for example a question mark, that cannot be converted to float. So if there is a problem while converting it to float, I am putting a NA is nothing but null value. Now okay, so now by seeing the info, we can see some of them have been converted to null values. Instead of 920, it is showing less number which is less than 920, 890 and 830, because the rest of the values are null values. Okay, so we can observe that this is still not converted to float 64. We'll come back to it in a bit. Okay, now by seeing the values, you can see that everything is converted. Now what we need to do, we need to convert those null values into something different. Only then we can see everything into float 64. Okay, so we are using the fill NA functionality. Fill NA means we are filling the NA value to one of the mean, or it can be ffill. For example, if you use this method ffill, it will do the forward filling. So whatever the value in the previous cell of the null value gets copied to the next cell. So that way all the null values will get the information from the previous cell. But I am using something called xmean. So that means I'm using the lambda function to take the column average and replacing the column average with the null value. So this is the method I'm approaching, and by doing this, all the null values get converted to average value. If you see now info, we can see everything gets converted to float 64, and even the null values have been replaced. So whatever the values which are missing here, 890, 830, those things have been filled with the average of that particular column. Now we have got all the data set ready. Now we can run the basic statistics of the data frame using the describe functionality. By using describe function, you can see age, 920 records are there. Mean age of all the people is 53.5 age, and then standard deviation is 9.4, minimum is 28, years, and maximum is 77 years, and you can see the median is somewhere around 54, and then sex is either male or female, so it is only two values, minimum is 0, maximum is 1. And these are some of the medical information. For example, CHOL can be a cholesterol, so overall 920, maximum value of this will be 603. You can imagine someone is having a very high cholesterol, and the minimum value of that is around 0. Okay, and the median value of the cholesterol is 221. Likewise, all the values have been captured here, and you can see the num, which is the output, is having a 0 value as the minimum, and the maximum is 4. So it can be 0, 1, 2, 3 or 4. 5 possibilities are there. Now what we are going to do is to run the correlation. Correlation calculates the correlation between the columns in a data set. So df.cor will calculate, and we can get the correlation matrix. So everything will be in the form of, if you see this, you can just see everything will be in the data frame, but the same thing can be represented. You can see the age and age correlation is always 1, sex and sex correlation is 1, but if you see age and let us say TRES TBS 0.23 correlation is there. So likewise, if you can see, there is a high correlation between THALACH to age. Even though there is a negative symbol, it does not matter, it is highly correlated with age. And you can see there is another one which is highly correlated, some 4.4 something here, right? The num value and the old peak, these two are highly correlated. But this is not a very nice way of seeing the correlation information. So if we use the heat map of SNS, SNS is nothing but Seaborn library, you can see it in a very pictorial manner. So the darker the value, lesser the correlation, lighter the value is higher correlation. So this is 0.39, you can pictorially see which is very well correlated. In fact, minus 0.36 is also very good correlation. Let's move on with some other type of analysis. Now we can use the box plot, which we have seen in the previous video, to understand individual column information, how the spread is, how many outliers are there. So these are all the box plots I'm plotting for different columns, and you can see this age, it's very nicely spread, there's no major problem here. And you can see CP is something on the upper part of the quartile is very much populated, and there is only one outlier here. And similarly, THALACH, CH is very nicely distributed with very less outliers here, no problem. But this is CA, seems to be highly concentrated somewhere. Data is somewhere like 0.25 range, but these are all very small values of data. Number of entries are very less. Looks like a lot of outliers here. Even here, old peak, lot of outliers here. Likewise, you can see individual columns. And now you can also do something called pair plot of Seaborn. Before doing pair plot, I'm going to scale all my data of all my data frame into min-max scalar. So the maximum value will be the value 1, and the minimum value is always 0. Everything is distributed according to their scale in their particular column. So that is what I'm going to do. And after executing this, we are also doing one more thing, is to plot the pair plot. So pair plot is nothing but takes all the columns and compare each column against each other by plotting a scatter plot. So that it's going to be a very big plot. That's why I'm going to use a bigger figure here, 25 by 25. And you can see that the entire plot is getting generated. It's taking some time, around 26 seconds, but it's going to plot a nice plot, which pictorially you can see how the comparison is happening between two columns. Okay, here you go. So you can see age versus, this is also age versus age. It is giving a nice histogram. If you see age versus, this is the CP, I guess, yeah, age versus CP, you can see both are categorical information, so that's why it is looking like this. And age versus this particular column, which is THALACH, it is looking like this. So basically you can see how the distribution of the data against each other, and you can also try to figure out if there is any kind of correlation among themselves. This is called pair plot, and we can also do scatter plot to compare among multiple columns. Okay, so same thing, whatever we have done scatter plot, this is also scatter plot, but you can use the scatter plot where you can pass the hue as number to see how the value, the prediction value, which is nothing but y value, how it is distributed compared to two columns, right? For example, if you plot a scatter plot against th, la, ch and old p and show the colors of 0, 1, 2, 3, 5, how does it look like? So that is the plot here, and all the lighter values are more heart disease, and 0, which is the dark values here, are the no heart disease. And here you can see a lot of dark values here and a lot of light values here. As the age increase and the th, la, ch is decreasing, I can see somewhere around we can draw a classification line, and here also you can see th, la, c versus ex, a and g. If the value is 0 about ex, a and g, it's mostly dark values, and value higher ax, a and g, mostly lighter value. So this way I can pictorially see these are all the features important for our analysis and machine learning. You can also do histogram printing, for example CA. If you want to see CA, how the values are distributed, we can use a particular column here and histogram. Likewise, if you want to print th, la, ch, print that value as well. So you can see this is nicely distributed as a normal distribution. One more thing, age. If you want to see how the age is distributed, so it is mostly normal distributed, right? And let us say we want to see num, the output variable, how many zeros are there and how many diseases are there. For example, this is very imbalanced set. We can very clearly see most of the out of 920, 400 values are having no heart disease, and rest of the things are having heart disease, but in different frequency, right? So this is the 1, 2, 3, 4, and having lesser and lesser values of patients for these many categories. Okay, so we will end this video at this point. We can do still a lot of more analysis, but what I wanted to focus here is how to take the data and try to build a story around it, right? And try to make sense of data, and also see if there is any correlation between the columns and what are all the features, what are the columns that could be features. We are going to do something called feature engineering, which means not all the columns can be directly used as a feature for our machine learning model. We might have to choose some of the columns as features. So that is also as part of EDA, we can also choose some of the features for our machine learning model. So that's all for today's video. I hope you enjoyed it. Thank you for watching, and please look for more videos, and if you like this, please give a thumbs up. Thank you very much. Bye.